Hello everyone, my name is Fidel Schaposnik and this is the first lecture for the Brazilian ICPC Summer School of 2022. This lecture will deal with training and contest strategy, so it will not have any technical content, but hopefully it will help you make better use of what we see later in these lectures. By the way, if you want to put a face to the voice, this is me. And I will be available during the Q&A sessions. I will also just try to show up at the gather space whenever I can. But since I'm on a different time zone, you can also email any questions you have to this address, and I will try to answer asynchronously. Maybe that's better for us to communicate or to answer longer questions. So feel free to ask any questions you have about the lectures or problems that I propose, and I will try to answer them as best I can through some means. So as a final comment, feel free to speed up the video, skip parts that you think are not interesting, either in this lecture or the following. I realize this system of giving lectures virtually has its drawbacks. I don't get any feedback from you in real time, so feel free to adapt as you see fit. Okay, so I hope you enjoy these lectures and learn something. Let's start. Okay, so the first thing I want to talk about is getting the basics right. So what are the basics? There's 3 points I want to make it very clear are really important. So the first one is typing. Now, I'm sure you think this is obvious, but programming as an activity is about typing. You type code, and what you type is the way that your thoughts go into the computer. So the faster you can type, the faster your thoughts can flow into the computer. And the computer can handle any speed. So the faster you type, the faster you will get your thoughts out of your head and into the computer. And if typing is a problem, I mean if you're slow or you make a lot of typing errors, what that means is your thoughts are not going to flow smoothly. They are going to be stopped every once in a while because you're either trying to think about the next letter to put, or you're trying to think faster than what you can type, and this is going to be a problem. So maybe you already know how to type, maybe you don't, so make sure you do. Make sure you can touch type, make sure you can touch type code, which is not the same as touch typing text, and also make sure you can get a decent speed. I don't know, maybe 90 words per minute is okay. Take it to 120 words per minute and you're really good. But if you're really a lot slower than that, it's going to affect the way you express your thoughts to the computer, and that's going to be a problem. So trust me on this. You should make sure that you know the mechanics of coding. So this is the first basic thing I think is very important. It's a shame that we are not taught about it in school. I think it's more important than a lot of computer science or computing classes that kids are taught at school. I wish they taught me typing. There's programs for this. You can download apps and just practice. Now, second is time. So you need to give it time. When you train, when you study, when you do any kind of activity, it requires time. It requires time to get good at it. And as a basic rule of thumb, I think that if you dedicate 1 hour per day to any activity, whatever it is, it can be a sport, it can be programming, it can be learning a language, cooking, whatever you want. 1 hour per day, you become better. And after some time, I don't know, a year or two, suddenly you will be much, much better than everyone else. This is just a fact of life. Most people don't spend an hour a day on any given thing, they just have jobs, they do other stuff, so they become good at one thing, which is their work. And if you spend 1 hour a day doing something, you will learn it and you will become very good and you will be impressive in that sense. So, 1 hour per day is the bare minimum. However, you don't just want to be good. You want to be really good, in the sense that you're here because you want to go to the ICPC World Finals, and people don't go there just because they are decent programmers or decent people coming up with algorithms. They are going there because they are really, really good at it. They are the best in the world. So 1 hour per day is not going to cut it, unfortunately. It's going to be good if you're, I don't know, you take up running and you start running 1 hour per day. After a year, 2 years, you will be, running marathons or something. But a lot of people run marathons and not many people go to ICPC World Finals. So you should give it more than 1 hour per day. Now, how much? Well, it depends on how you use that time, how effective it is for you. As a recommendation, I can only say give it as much time as you can spare. I know you have a life, you have, whatever, family, friends, studying, work, maybe. You have a lot of things to do, but you should really think that the more time you invest in programming and programming competitions, the better you will do at them, as in anything else in life. And you should, make sure that you're giving it the right amount of time. Otherwise, there's no way you're going to improve. Now, the third thing, and it is related to the previous one, is you need to stay healthy, right? So this, again, is obvious, but it's important that I mention it just to begin with. You need to be healthy and strong to compete in programming competitions. Not just because they are 5 hours long, and if you're like me, at the end of those 5 hours, you're hungry, thirsty, sweaty, really tired, but because being healthy helps you train and helps you do better in programming competitions. So if you don't do any exercise, you should do just like, competitive gamers exercise. They spend hours and hours playing online video games. This is not obviously sitting for hours and hours. It's not good for your body. So you should, do some exercise, go out for a walk, run, swim, play tennis, whatever you like, whatever makes you, do something outside. This will help you later when you're concentrating on solving problems, just pouring all your mind into the basic problem that you're trying to solve. Otherwise, you'll be uncomfortable, get tired, have pain in your back or whatever. So remember, stay healthy. This also includes sleeping well. There's no point, in doing 8 hours of studying if you're too tired to remember anything. So try to, manage the time you dedicate to programming competitions and the time you dedicate to yourself, to staying fit and healthy. And if you do these two things, you can make like a lot of improvement much quicker than people who are either not giving it enough time or giving it a lot of time but not really making use of it because they are not in the best form. Okay, so related to the previous slide, I want to talk about honesty. So here, this is also important. It's important because it will help with everything else I say. So you need to keep yourself honest. Obviously, no one is going to be policing you, so you need to be your own police. And for example, if you say that you can type fast, don't just say it. Go measure it and make sure that what you think is true is also true, right? So you may think you can type fast and then you go to some website and you start typing code and it turns out you're not fast. Well, you need to work on that. if you say that you are training for 8 hours a day, that's great, but if you really are not, then you're fooling yourself, and this is going to affect the results you get. So it's okay if you don't spend that 8 hours a day training. I don't spend 8 hours a day working. I work maybe 5 hours on a good day, but I make sure that if I say I work 5 hours, I know I've worked 5 hours, and then this helps me think, okay, I didn't get the job done. Well, sure, it was a job that took 8 hours and I worked 5. This is understandable. So, keep yourself honest. Don't lie to yourself. This is just not good for any kind of activity that you with a long-term goal. To reach your long-term goals, you need to be honest about what you're doing to reach them. So one way that I find very useful to keep yourself honest is to keep a log, right? So keep a log about anything that you do related to to competitive programming. So keeping a log means recording, for example, number of problems solved. You can also, number of hours spent. These kind of things. Try to keep a log about what you're doing, and then maybe 1 week you're going to see that you spend more time, you solve more problems, and suddenly you feel you're a bit better. Well, this will help you understand why. So try to stay honest about the training that you're doing. Try to keep your teammates honest about the training that they are doing. And if you then pay attention to your log, maybe after, a few months of keeping it, you will really notice when things are going the right way or the wrong way. So this is another, I think, basic thing that helps all along your training. The next thing I want to talk about is programming languages. So it used to be the case when I was a contestant that you could basically choose only between C++ and Java. Knowing your language is important because the better you know it, the better you can express yourself in that language, and the easier it will be to code what you're thinking you want to code. Now, you have many options nowadays about languages you can choose, and it's important that whatever you choose, you know it, right? That you really get to know it inside out in as much detail as it's possible for you, because that's going to help you a lot to write quick, easy, bugless, efficient code. Now, you can also know more than one language. Typically, you could choose maybe one main one and some other languages. Maybe you're a C++ coder, but you know some Python, or a Java coder, but you also do some Kotlin. That's okay. You may not know both in the same depth, but if you know 2 languages or more, you can then really optimize what the language choice is for each problem that you're trying to solve. Maybe some easy problems are going to be easier to solve quickly in Python. Other problems, maybe harder ones, or the ones you really need to squeeze out all the efficiency, you go for C++. This just gives you more options. So, try to learn the one language that you're most comfortable with, learn it inside out. Then if you can spend some time playing with some other one, it's going to be useful too. Now, one key point to getting to know programming languages is reading code. So read as much code as you can. This includes code that your teammates write, code that other people write. There's many platforms where you can see other people's code, like in code forces and so on. So try to read a lot of code by people who are better at some programming language than you, and you will learn new tricks, new techniques, new ways that you can use the language tools, and this will really help you to learn the language. It's much better to read code and try to understand. You also try to understand the algorithm behind, so you're also learning something about algorithms. but it's much easier than just, grabbing a thick book about C++ and starting to read about templates or something. You will learn the actually useful stuff if you read code by some good competitive programmers. Next up, how to train. So let me suggest one training technique that I think is very good. It helps a lot for programming competitions, and it's what people usually call classical training. So this is classical in the sense that it's used for all the classic disciplines, such as playing the piano or the violin or dancing ballet, whatever classical art form you choose. People have been training in the same way for hundreds of years, and you can summarize the way this training works by the following diagram. You first train slow, then you train fast, then you do normal. So the theory is that you have a trade-off between one axis that we can say is related to speed, in this case the speed at which you program, and a different axis on the opposite direction that is related to correctness. So how good your algorithms, your programs are. So you want to be somewhere here where your code is both rather fast and rather correct the first time you write it, and then you start debugging. But you cannot just train in that area. So in order to improve more and to push this axis to both sides, so what you want to do is first try to solve problems very slowly. So you try to go all the way here, and whenever you approach a new problem, you really think it through deeply. You code very slowly, you make sure you're not making any mistakes, you make sure you have no bugs. You try maybe you try to not compile until the very end and make sure that things compile and work on the first try, but you really try to make sure that whatever you do is correct. This will help you get into your head that you should not make mistakes. Of course, this takes time, and then you will be slow, but in this mode, in the slow mode, you do not really care about it. You just take your time and code as slowly and as correctly as you possibly can. Next, you go to the other opposite and you try to do like really fast coding. So this again is hard. You need to just read a problem and then just start typing immediately. You will find that it's hard to actually think about the structure of the program. You don't have a clear idea of what you're trying to do when you're starting, and you just start and immediately try to get the solution. This what this is going to lead you is to making mistakes, to choosing suboptimal strategies, to having a lot of bugs in your code. But this is also going to train you to really make things work faster. So if you were a violin player, you would have started playing whatever theme you're playing very slowly, and then you just repeat it like you're crazy, and you may miss notes, but you don't care, right? Finally, you should train in the normal mode, which is somewhere in between, and it depends where will depend on the problem you're trying to solve. So easier problems, you can push a bit that way, make them faster and not care so much about correctness because they are easy and it's unlikely you will make any mistakes. Harder problems, you will want to push in that direction a bit to make sure they are at least have a chance of being correct, because it's pretty hard what you're trying to do. But in general, this is the area where you will finish working on during a competition. The whole point of this technique is trying to stretch this trade-off so much that the whole region of where you feel comfortable, maybe there's a whole region around here where you feel comfortable, solving problems. This region should stretch and should include pretty fast speed and pretty slow speed, and different degrees of correctness of code, let's say resilience, which this will help you to adapt to different problems, right? Eventually, the whole point is also you will move both axes so that you start coding with more speed and more correctness. But first, you need to really be comfortable in a wide region here in the middle. I think classical training is one of the best tools that you can use to improve your coding skills. Now, there's some other things that you can do and some other things that you should not do. So here are some tips for individual training. Now, one thing that, of course, all of you know is about online judges. But, okay, you can use them to train. You find problems, you submit solutions at your own pace, that's nice. Now, online competitions, real-time competitions, are a completely different story. They are very important because they let you simulate the tension, the finite time element of a real competition. And I think they are crucial to practice how's it going to be to go to a world finals or to a regional contest where you have a fixed amount of time and a fixed set of problems, and it's not just you choosing some problem you want to do next. So participating in online competitions as an individual, be it in Code Forces or Code Jam or whichever competition you find and the format you like, I think it's very, very good to really put a bit more of pressure and a bit more realistic conditions to your training. Even if you don't necessarily consider them as a competition where you have to do the best that you can, try to do them to get a feeling for how the actual competition is going to be. Another thing that you should do is ask for help. So I can't stress this enough. It's important that you don't get stuck with some problem and waste a lot of time trying to figure it out. I mean, it's important to figure it out, but it's also important not to waste your time. So you should ask for help when you feel you've dedicated enough to a given problem and now you want to move on. You ask your teammates, ask a friend, ask in a mailing list, in some forum, you go and read the solution. Whatever you do, you want to actually, learn what you need to learn to solve that problem and move on. So if you get stuck a lot and you spend a lot of time being stuck, it will be frustrating, it will be a waste of your time. So don't be afraid about asking for help, looking for help, because once you've received this help, the next time hopefully you won't need it. So these are things that I think you should try to do. And there are some things you should try not to do. So one of the things that you should try not to do is, let's say, under aim. By this, I mean you should try to not just go for problems that you can solve. So sometimes when you're training, you will find yourself just going always to the problems that you know you can solve, and you just go and code them and you get the correct answer, and that's nice, but this doesn't help to push your abilities. So don't just stay in your comfort zone. And related to this, another thing that you should not do is be lazy and avoid those problems. So you should also not avoid the problems that you think you can solve, because otherwise you will lose touch with what you can actually do. So if you're always saying, yeah, I can do this, I'll just skip it and move on, then it will turn out that you lose practice and you will not be able to do that as quickly and as correctly as you would like. So when you find a problem that you can solve, you solve it and you move ahead. Don't just go looking for them, don't just skip them. Finally, something you don't want to do also is to forget. By this I mean that maybe you did a contest and you found some problem that you could not solve. Or maybe you tried to solve it and you thought you had a solution and you have a bug, you cannot find it, and okay, the contest ends. You just switch off, move on with your life, and never come back to this. This is a bad idea because you never actually solve this problem. You may know what the bug is, or you may be confused about what the bug is, and you will, if you actually fix it, you will realize maybe your fix didn't work, maybe it was not the fix, maybe that was not the problem. So when you cannot solve a problem, don't forget about it, keep it in your head. You can go ask other people for help, but you can also just keep it in mind as something that you did not solve, that you may want to come back later, because you learn by understanding your mistakes and not making them again. If each time you make a mistake you forget about it, you don't really learn much about them. So these would be, in my opinion, the things that you don't want to do when you train. Of course, ICPC is a team competition, and that means that a lot of your training is going to be as a team. Okay? Now, there's no replacement for this. You really need to know how your team is going to behave during a competition, how you're going to distribute tasks, do different jobs that you need to do. And in order to know this, you need to repeat as closely as possible the competition conditions as many times as possible. In particular, this means you should take 5 hours at least once a week, hopefully more, to simulate a contest. So you want to take 5 hours straight, you don't want to rest, you want to really do as in a real contest where you're given 5 hours, some problem set, and you just have to solve as much as you can during that time. That also means that you should use a real problem set. You don't want to, choose a set of problems to solve yourself. You want to use a problem set that was chosen by actual problem setters, because those are balanced, they have different types of problems, they have different difficulties. So using a real problem set will be the closest thing that you can do to a real competition. Now, that means take a regional contest, a world final contest. You can choose the problem set according to how hard you want the simulation to be. But using a real problem set will ensure that you're actually, trying to get something done that is both doable and it will let you compare your performance with whoever took that contest in the actual event. Also, because you want the conditions to be as similar as possible to what you had, what you would have in a real contest, you want to use one keyboard, right? You're allowed one keyboard during the competition, or at least this is the standard rule. And if you're allowed one keyboard during the competition, you should be allowed only one keyboard during your simulation. This also means, therefore, that you should write code on paper. when someone is on the keyboard and you want to, you know, advance some work on some problem, what you need to do is start writing code on paper so that when you're given the keyboard, you can actually just go there and write, quickly type whatever you have already written on paper. So these two things are important for you to not, you know, artificially save time during a simulation by just typing code in some other computer while your teammate is working on his computer. Finally, you also want to use, if possible, a printer and just print code for debugging, right? This will let you debug while someone else is using the computer, and this is also the situation that you would have in an actual competition. If you cannot have access to a printer, then okay, use a different screen, a different computer, but make sure that you're not modifying the code in that computer. You should just use the computer to read the code that you wrote, and then when you need to actually make some modifications, then you go back to the actual computer that you're using to simulate the contest. You should also work on your pacing strategy. By this I mean, let's say you're given your 5 hours, right? And you need to solve problems during these 5 hours, but of course you're not going to solve all the problems. So this is t equals 0, the start of the contest. This is t equals 5 hours, the end of the contest. And what you want to do is essentially split these 5 hours into different sections such that everyone knows exactly what they are doing at each point during the contest. So a typical strategy, which of course nothing of this is fixed, but there's more or less some standard choices. So for example, before t equals 1, you could say that this section here is basically where you get to know the contest. Here you read all the problems, and by that I mean really all the problems. You don't want to leave problems unread further than this, because maybe they are easy and you know you should have read them and solved them early on. You also want to tabulate the problems. That means create a table of each problem and your estimate of difficulty, maybe some comment that you can give about that problem that your teammates may find useful, and ideally you want to order them in the order of difficulty or the order in which you think they should be solved. So these three activities should be done early on in the contest, because this is going to inform the rest of your strategy. You should make sure that they are finished maybe by 1 hour, earlier if possible, but sometimes reading like many problems just takes time. But anyway, during this time, you're supposed to maybe not be coding or thinking about solutions so much, but really processing the contest to learn what the best strategy for heading the rest of the contest is. Now, from hour 1 to, I don't know, maybe this would be 3.5 or maybe 4 hours. This is the main part of the contest. This is where you write solutions. And here you should make sure that you follow some basic good practices. For example, you should rotate coders to make sure that whoever is in the computer doesn't get really tired early on. You should also parallelize as much as possible what you're doing. So if someone is coding, someone else can be maybe thinking about solutions, writing code on a different problem on paper. The other person might be debugging, but you should try to, not have two people working on the same problem at the same time. And if they do, they should be doing it on purpose, like in pair programming, helping each other and not individually repeating tasks, which is just a waste of time. Now, it's important during this section to also make sure you correct any mistakes that you make as soon as possible. That means if you find something new, maybe about some problem you thought was hard becomes easier because someone knew the solution or something like this, try to correct any mistakes that you did here in the first section, right? Now is the time to correct them, and you should still correct mistakes as bugs and so on as you go into this section, because this is when you have time. This is when you're more or less fresh, also your mind, and this is the best time to correct mistakes. Towards the end, you will have a lot of trouble correcting mistakes because it's going to be, you're going to have little time, you're going to be tired, you're going to be nervous. So, try to use the first 4 hours of contest more or less to write good code, write good solutions, try to leave things in a good shape for the last section. So the last section here is the closure of the contest, and this is special because you want to make sure that you harvest everything that you did in the previous sections. By that I mean, at this point, it's sometimes useful to take a break. You want to stop, even take all three, take a break and discuss for 5-10 minutes what you're doing, how is that going to help until the end of the contest. Sometimes someone is like debugging and they've been debugging for an hour, and you have to really ask them, are you actually sure that you can finish in the time that we have left? And if so, is it important enough to get this problem done that nobody else is going to use the computer during this time? So taking a break is important to look back. You should look back on what you accomplished here and see how you can make the best use of that. If you have many problems that have not been solved, but you have code for them, choose the ones that have a highest probability of being fixed and concentrate on those. Usually it's just maybe one that you can actually try to solve. So you choose that one, and maybe 2 people, 3 people just stare at the code or even rewrite it from scratch. But you really, if you had the solution and you're sure the solution is correct, you want to get this thing done. It's important to use this section here, as best you can, because as the contest finishes, you get more nervous, you make more mistakes, and it's a very bad feeling when you go out of the contest and you feel like you could have done much more. So this is the section where you want to avoid that by just closing the problems that you have already started working on, discarding some ideas that maybe they were good, but you didn't have time to do. You just discard them, put them out of your head, concentrate on what can be done before the 5-hour deadline. Now, after you finish a contest, you do contest debugging. And this is important either for real contests or for the contest that you use as practice. So what does it mean to do contest debugging? It means trying to analyze your performance, trying to analyze what happened, and learn from what happened to improve on the next iteration. So there are some common problems that you might identify, and once you identify them, you have to actually keep them in mind so that the next time you are able to avoid them. For example, let's say you have many solutions that are never coded, right? You read all the problems, you've thought about them, maybe you've thought about solutions, you had the solution, and you actually never got around to coding them. Why? Well, maybe because someone was cloning the computer because they were debugging, or maybe you did not write code offline, so then when you actually had to write the code, it turned out to be harder than you thought, and you spent a lot of time on the computer. Maybe the person who is always writing code was very tired, and by the end they were making a lot of mistakes. So if you have many solutions that were never coded, you should try to improve those things, rotate more the coders, debug offline, write code offline, do things that will help you, have a better turnaround. Another common problem that you may find is that maybe, you write lots of solutions, but then it turns out you get a lot of wrong answers. What does it mean? Well, probably it means that you have set your goals a bit too high. You thought that you had solutions for many problems, but then it turns out maybe you did not think about corner cases, you did not actually think about the correct algorithm, you did not prove that your algorithm was correct, you just had the intuition that it would work, but it didn't. So in this case, you have to choose more carefully what you want to code and also what you are able to debug. So instead of writing lots of solutions and getting lots of wrong answers, you want to write fewer solutions and try to make sure you get at least some accepted solutions. Next, something that is also common, especially for beginning teams, is to get lots of time limit exceeded answers. So if you get a lot of time limit exceeded judgments, that means you're probably rushing to solutions that are suboptimal or coding them too inefficiently. In either case, you need to stop rushing to the computer when you have a solution, and you need to analyze it better, you need to discuss it with your teammates, and to think better about how you're going to code them. Really, sit down and do the hard work of figuring out the complexity of the solution and figuring out all the details so that you are sure that the solution not only works, but works in time. Another thing that is sometimes happening in contests is you have nothing to do, right? When you have nothing to do, you're either extremely good and you solved all the problems, and I'm assuming that's not going to be the case, and then when you have nothing to do, it means that all the problems that you actually have left to do are too hard for you, and you don't even have a start of an idea to solve them. So this means that you have achieved some sort of bound on your ability to solve problems, and what you should try to do is solve harder problems in training. Maybe read theory, read some tutorials on algorithms, learn new techniques. If you have nothing to do in a contest with maybe, more than 1 hour, it's normal if the last 15 minutes you don't have anything to do because it's not enough time to solve a new problem maybe, or you've given up debugging something. But if you have nothing to do for more than 1 hour, then it means you should really be able to tackle harder problems, and in order to do that, you should actually train with harder problems and train to learn more techniques. What else can go wrong in a contest or a simulation? So, for example, you may get too many wrong answers before getting some problem accepted. So this is also common, and maybe what's going on is you're not testing enough. So it's it's very common that teams will just code a solution, see it works in the provided examples, and just submit. This may be okay if you're pretty confident that your code is correct, but you should actually probably write some examples yourself, try to think about border or tricky cases, and do that kind of testing before submitting, or at least before resubmitting after you found the first bug. So if you get too many wrong answers before getting some accepted solution, you need to improve your testing before submitting. This is actually important to get your penalization time to be low, and it's also important not to waste time, doing a lot of debug submit iterations, which actually take time. Another thing that can go wrong, and that usually goes wrong, is debugging is slow, right? So a major waste of time is when someone is slow at debugging some problem, and then everyone wants to use the computer and nobody can because they are like trying to find the problem, or maybe doing they need the computer to debug and print out stuff. So when this happens, you need to change the way you debug. So if you can debug offline, sure, that's good. But if you're going to be online on the computer, for example, you can try getting a teammate to read the code with you. You explain the code with your teammate and maybe they will find the bug or ask the precise question that will let you find the bug. So this would be like pair debugging. It really helps when you're stuck debugging, and it helps you to be faster at debugging, which can be a problem that you have, especially on hard problems. Another thing, and maybe this will be the last example I give you about things that you may identify are going on in a contest that you may have to work on, and that's okay, it's not a bad problem to have, but it's still a problem. It's about coming up with too many solutions. This means that you have solutions for problems that you are not able to code. You either come up with them during the contest but too late to be able to code them, or you come up with them after the contest. Now, if this is the case, you should really go back to that first stage in your contest spacing strategy and work on identifying the problems that you can solve early on. If you find out in the last hour that you could have solved the problem in the middle because it was pretty easy and you just needed 1 hour, but now you don't have enough time, then this is something you need to work on just the beginning of the contest. You need to have identified that problem as one to give priority to early on. So, of course, there's many other things that can go wrong. These are just examples. I encourage you after each contest simulation or after each contest to take some time, at least half an hour, to discuss with your teammates, to sit down. You usually want to look back at the table that you made during the beginning of the contest and see what you did, which were your strategical mistakes, which things did not turn out to be as you thought they would turn out to be. And this kind of post-mortem analysis will really help you identify the areas where you need to work on. So unless you do this, you're going to be a bit blind when you're simulating contests. You're going to just either see that you do well or you do bad, but you don't know how to reproduce the situation where you do well. So it's going to be like walking with a blindfolded. You want to actually look back to what you did and try to extract the most information of those 5 hours you spent, because during that time it's very hard to pay attention, but after that you can pay attention and you can get a lot of knowledge out of your performance. Okay, so we're coming to the end of this first lecture. I know maybe many of these things you knew. Hopefully I've invited you to think a bit more about what you do on a meta level, not just about the algorithms and the code that you write, but about how you write it, why you write it, and how you can improve your training and your approach to programming contests. And the last thing I want to say is, above all of what I said before, the most important thing is to have fun. So I will write it, and you should keep this in your head at all times. Make sure to have fun. Make sure to enjoy the whole process, because otherwise there's no point in doing it. There's no point in taking part in a programming competition if you don't enjoy the whole process of training, competing, discussing problems, analyzing them, learning new things. This is the actual part that you're going to remember for the rest of your life, not the actual problem that you solve or don't solve in some contest. So make sure that you like your teammates, make sure that you have fun together, make sure that whenever you train, you're doing it not as a core, not as something that you dread, but something that you look forward to. If you have fun, I am sure that you're going to improve. I am sure you're going to enjoy the whole thing a lot more, and that's going to allow you to be much, much better.